A quick new idea daily from the world's greatest TEDx talks. I'm your host, Atossa Leoni, and this is TEDx Shorts. The human body performs a countless number of tasks to heal and defend itself, from fighting back a cold to recovering from invasive surgery. Tal Zaks is a chief medical officer at Moderna who offers a cutting-edge future. If we think of our bodies as computers, with our cells acting as the hardware and our genetic material the operating system, what if we could upgrade ourselves for a few lines of code?
I'm here today to tell you that we're actually hacking the software of life and that it's changing the way we think about prevention and treatment of disease. So here's all the biology you need to know in 30 seconds. Our body is made out of organs. Our organs are made out of cells. And in every cell, there's this thing called messenger RNA, or mRNA for short, that transmits the critical information from the DNA, our genes, to the protein, which is really the stuff we're all made out of. This is the critical information that determines what a cell will actually do. And so we think of it like an operating system. And it's not just in every cell of our body, it's actually in every cell of every organism alive. It's the same thing. And so if you could actually change that, which we call the software of life, if you could introduce a line of code or change a line of code, it turns out that has profound implications for everything from the flu to cancer. And I'm going to demonstrate that with 3 short examples. Let's start with the flu. So many of us get a vaccine. It is an injection in our arm where we get bits and pieces of the virus, the proteins, and that teaches our immune system to recognize the virus. Now imagine if instead of giving the protein, we would give the instructions on how to make the protein, how the body can make its own vaccine. So the traditional approach has protein floating around your cells. An mRNA vaccine approach has the cells themselves in your own body making the vaccine. What's more alarming, a stranger prowling the neighborhood or somebody who just broke into your ground floor and tripped the alarm? That's what happens with an mRNA vaccine. You've tripped the alarm wire, and now the cell is dialing 911. It's calling the police at the same time as it's making the protein and saying, that's the bad guy. That's how an mRNA vaccine works. And for the last several years, we've shown this actually works in a whole multitude of animal models. We took a group of volunteers and injected them with a messenger RNA vaccine against a variant of flu, influenza. And all of these volunteers got the immune response we were hoping to see. The side effect profile was pretty benign, what you would see with any normal type vaccine. So we've proven the principle, this actually can work. And now we're going to be developing a whole slew of vaccines against diseases for which we don't have one. Let's talk for a minute about cancer. Horrible disease. Cancer has affected the lives of many of us and will affect the lives of many more of us as we age. The problem with cancer at the cellular level is that the DNA is screwed up. You've got these mutations, and this screwed up DNA leads up to screwed up information that makes screwed up protein. And so the cell loses control. Now, how do you figure out what is actually screwed up? Well, you got to figure out the whole sequence, right? So now we can go and figure out what exactly is screwed up in a patient, and we can use that information to make a vaccine. We take that information, say a patient with lung cancer, and we take the biopsy, we figure out the sequence, we figure out their immune system, and that all becomes information. It goes up in the cloud into a bioinformatic algorithm, and then makes a vaccine that we administer into their normal tissue, into the muscle, to try and wake up their immune system. Now, the challenge, of course, is that every person's cancer is different. And so to do this, you have to make it personalized. But if every patient is different, what we're going to have to do is make a personalized cancer vaccine for every patient. And that's exactly what we've started to do. Every patient gets a vaccine that's based on the sequence in their own tumor. If you think about what it is we're trying to do, we've taken information and our understanding of that information and how that information is transmitted in a cell, And we've taken our understanding of medicine and how to make drugs, and we're fusing the two. Imagine a world where we can not just diagnose, but we can actually use the information to create vaccines, to wake up the immune system to something like cancer, and to fix the missing information for children with diseases so that they can live the ICU and live a healthy life.
The TEDx talk you just listened to was recorded at a TEDx event in Boston, Massachusetts. All TEDx events are independently organized by volunteers who believe in TED's mission of ideas worth spreading. Special thanks to the organizing team at TEDxBeaconStreet. Visit TED.com/TEDxShorts to listen to the full talk and learn more about TEDx Shorts. I'm Atossa Leoni. Thanks for listening, and see you next time.